Penning or tracking shots are captured by a camera following a moving object. In such photos, the moving foreground is sharp, but the background is blurred. This creates an artistic effect of foreground motion. Such shots, however, are hard to capture, even for professionals, and typically require complicated hardware setups. We present a system that helps novice users to create high-quality tracking shots from a short video. Given an input video, we first ask the users to quickly segment the foreground object using RotoBrush. The segmentation does not need to be very accurate. This step is quick and requires a small amount of user interaction. We automatically reconstruct a 3D scene. Then, we reconstruct a dominant 3D foreground trajectory. We simulate a virtual camera that moves along the foreground trajectory. By projecting feature points to this camera, we generate a spatially varying blur field that is aware of the foreground motion and scene structure. The final tracking shot is rendered by convolving the video frame with the blur field. Here we show some examples generated by our 3D method. Our non-rigid structure from motion method can reconstruct highly nonlinear 3D foreground motion trajectories from a single video. The exposure time can be controlled by the user. We also developed a pseudo 3D method which does not require structure from motion. Thus, it can handle more general cases. Here we show a few examples. Using the pseudo 3D method, the scene scale can be controlled by the user. This provides the flexibility to synthesize different amounts of blur. For more details, please refer to our paper. To quantitatively evaluate our system, we render a few dynamic scenes in Maya. For each scene, we render a short video from a shaky camera as the input to our system. We also render a ground truth tracking shot. The two cameras share a common base frame for purpose of comparison. As we can see, both our 3D and pseudo 3D methods can produce similar results compared with the ground truth. Here we show one more example. There are commercial tools for creating artistic blur on an image. Let's first take a look at Photoshop's blur gallery. Here we show the motion blur function in the blur gallery, the radial blur function, the tilt-shift blur. Let's take a look at Google Analog FX Pro 2. This tool allows the user to manually place some linear blur dots on the image. However, all these tools are limited and cannot be used for generating convincing tracking shots. In order to compare our results on real data, we developed a tool which allows the user to manually specify sparse blur kernels to create a tracking shot. The user can draw different shapes for the blur kernels and go back and forth to view the results. We also implemented a 2D method based on foreground alignment and optical flow. Since automatic feature tracking often fails on dynamic objects, we asked the user to manually mark feature points on each frame. We then try to stabilize the foreground based on marked feature points and compute optical flow between neighboring frames on the foreground stabilized video. We concatenate optical flow vectors to form the blur kernels. Experimental results show that our system significantly outperforms the 2D method and manual tools, both quantitatively and qualitatively. It further suggests that the 3D and pseudo 3D methods generate similar quality results. Please refer to the paper for more results. Our system has some limitations. If large smooth regions are present, it may not be handled properly due to the lack of track feature points in these regions. Our system may also fail if the camera undergoes a quick rotation. In this example, the tracking direction is inconsistent with the object motion. In summary, we present the first interactive system that can help novice users to create high-quality 3D-aware tracking shots. Traditionally, this is only achievable with expensive hardware and advanced skill sets. The required user interaction in our system is minimal and intuitive. Thank you for watching.